Most students panic when they see a second derivative and have to find the original equation. Today, we are going to solve this problem step by step. Let's start with part A. The question is asking for the original function. In order to get from the second derivative back to the original function y, we need to integrate twice. So let's start finding our first derivative. We start with d squared y over dx squared equal 6x minus 24. To integrate 6x, we get 3x squared. To integrate negative 24, we get negative 24x. So the integral of 6x minus 24 dx is 3x squared minus 24x. Since it is an indefinite integral, don't forget the plus c. Now we start solving for c. The question tells us there is a stationary point at 2 and 5. This is the key. Always remember, at any stationary point, the gradient dy over dx is 0. So, when x equals 2 dy over dx equals 0. Let's substitute in those numbers into the equation. dy over dx equals 3x squared minus 20, 4x plus c. 0 equals 3 times 2 squared, minus 24 times 2 plus c. Solving for c, we get c equals 36. So, our gradient function, or first derivative, is dy over dx equals 3x squared minus 24x plus 36. Remember what we talked about at the beginning of this video? To go back from the second derivative to the original function, we are going to integrate twice. So, let's start our second integration. To find our original function y, we will integrate the function 3x squared minus 24x plus 36 dx. The integral of 3x squared is x cubed. The integral of negative 24x is negative 12x squared. And the integral of 36 is 36x. So, our original function is y equals x cubed minus 12x squared plus 36x plus c2. Notice that we used c2 for the second integration. Since we used c for the first integration, we are going to use a different variable to differentiate between the first and second integral. So let's find c2 now. We will use the coordinates 2 and 5. When x equals 2, y equals 5. Let's substitute into our second integration. Y equals x cubed minus 12, x squared plus 36, x plus c2. So, 5 equals 2 cubed minus 12 times 2 plus 36 times 2 plus c2. Solving for c2, we get c2 equals negative 27. So our original function is y equals x cubed minus 12, x squared plus 36, x minus 27. Now for part B, the question is asking for the other stationary point. So how can we find that? Remember, stationary points happen where the first derivative equals 0. We already gave dy over dx equals 3x squared minus 24x plus 36. To find the stationary points, we set this function to 0. So 3x squared minus 24x plus 36 equals 0. Can you notice the common factor? Yes, 3. So let's factor out 3. We will get 3 into x squared minus 8, x plus 12 is 0. Now let's factor the quadratic to get our roots or stationary points. So 3 into x minus 6 into x minus 2 equals 0. We already knew about x equals 2, so the other stationary point is at x equals 6. Let's solve the last part, c. The question is, are these stationary points, 2 and 6, a maximum or a minimum? We are asked to determine the nature of those stationary points. In order to do so, we use the second derivative test, which we are already given in the question, d squared y over dx squared equals 6x minus 24. When x equals 2, we get 6 times 2 minus 24 equals negative 12. Since negative 12 is less than 0, we know that the curve is frowning, or we use the term concave down. This is a local maximum. Now let's test when x equals 6. So 6 times 6 minus 24 equals 12. Since 12 is greater than 0, the curve is smiling, or it concave up. Therefore, this is a local minimum. And there you have it, from a second derivative to a full curve analysis. If this step-by-step breakdown helped, hit the like and subscribe buttons for more math tutorials.